Jai Hind everyone. My name is Anuradha Dhumale. I am from CSE Department of Ajay Kumar Garg Engineering College. Today my subject is Database Management System and my topic is scheduling. Okay, so let's start with the scheduling. In the previous previous video, we see what is the scheduling. Now we in this video we will solve the example of how to check the conflict serializability of the schedule. So here is one problem for the conflict serializable or not. Here is one example of schedule like R1 of A, R2 of A, R1 of B, R2 of B, R3 of B, W1 of A, W2 of B. So T1, T2 and T3. Okay, T1, T2 of T3. How to write this? If R1 is if 1 is mentioned here, that means it is the operations of transaction 1. R1 of A, after that R2 of A, after that R1 of B, okay, R2 of B, R3 of B, W1 of A and W2 of B. Okay, this is our transactions of scheduled S. Now the first step is identify the conflict pairs of the schedule. So here are three. I draw here 3 vertices, that means T1, T2 and T3. So we have to draw the edges from non-conflict pairs. So from conflict pair. Okay. So here the conflict pairs are read. First check for the conflict pair. Check for the read of A. Is there any conflict pair? For the read of A, check the pair which is having one write operations on the same data. So there is no read of A. There is no conflict pair for read of A. Then again check for T2 read of A. Is there any conflict pair? Yes. From T2 to T1. T2 to T1. This RA is conflict with W of A. Okay. RA is conflict with W of A. Okay. So from T2 to T1 we draw one edge. After that check for the read of B. Read of B is having some conflict pair in transaction 2 or transaction 3. Yes. Read of B is having transactions in T2 which is having the write operations on the data B. Okay. So from T1 to T2 is also there. One edge is draw from T1 to T2. Now for the read of B of transaction T2, is there any conflict pair? No. Is there any conflict pair? Read of B and read of B is a non-conflict pair. So we can't draw that T2 to T3. Okay. After that, for the read of B, of transaction T3, we have to check the, is there any conflict pair for the read of B? Yes. From T3 to T1. This is the W of B is the conflict pair. So we draw the from T3 to T1. So we draw the edges from the vertices which is having the conflict pair. Now check the precedence graph. Okay, this is our precedence graph. Now check the precedence graph. Is there having cycle? Clearly there exists a cycle in the precedence graph. Check. From T1 to T2, one edge is there, and from T2 to T1, another edge is there. Okay. So the given schedule S is a non-conflict serializable schedule. In previous video, I told you that if the precedence graph is having a cycle, precedence graph is having a cycle, that means that schedule is a non-conflict serializable schedule. Okay. And if the precedence graph does not having a schedule, if precedence graph does not having any cycle, that means that schedule is a serializable schedule. Okay. Here we we write some conflict pair, read 2 of A and W1 of A, which I told you here in this example, okay, and we draw a precedence graph here and check whether the cycle is forming is there or not. If cycle is forming, that means this is the non-conflict serializable schedule, and if the cycle is not forming, that means the schedule is conflict serializable, okay. Now, with the second example, check whether the given schedule S is conflict serializable or recoverable or not. So, the transaction is T1, T2, T3 and T4. We have to check the schedule is conflict serializable or non-conflict serializable. For that, first, what is the first step? First step is we have to check the conflict pair. Is there any conflict pair is in this schedule? Check for the conflict pair, so that we have to draw the precedence graph. How many transactions are here? Here are the 4 transactions. So, we have to draw the 4 vertices here. Okay, 4 vertices here. Now, check for the conflict pair. Here, R2 of X is having any conflict pair. Check is there any read of write of X operation is there? Yes, in T3. We can see that in T3 there is a write of X operation is there. So, T2 from T2 to T3 one edge is there, T2 to T3. After that, checking for read 2 of X again is having any conflict pair in T1 and T4 also. So, we can see that from T2 to T1, from T2 to T1, that means read of X is having a conflict pair with W of X, right? So, we have to draw the edge from T2 to T1, T2 to T1. We draw the one edge from T2 to T1, okay. Next, we are checking for the W of X. After the read of X, the next operation is W of X, okay. So, we are checking the conflict pair for W of X. Is there any conflict pair for W of X? Yes, we can see that, see, from T3 to T1, from T3 to T1, the right of X and the right of X and the right of X operation is performed. Both the right is having the conflict pair on the same data, okay. So, we have to draw the edge from T3 to T1, T3 to T1, okay. Now, the next is W3 of X is having any conflict pair with another transaction. In another transaction, let's see, in the T2, is there any X performing any operations on X data? No. In T4, R of X, okay. R of X and W of X is having the conflict pair. So, from T3 to T4, T3 to T4, okay. From T3 to T4, one edge is drawn. Now, checking for the W3 of X and, okay, this is done. Now, W1 of X, after the W of X of transaction T3, the next operation is W of X of T1. Okay, let's check the conflict pair with W of X. Is there any W of X having conflict pair? Yes, in W1 of X is having R of X. Okay, this is the conflict with the R of X. So, we have to draw the edge from T1 to T4 also. T1 to T4 also. Okay. Now, W of Y, after this T1 transactions, W of Y is the next operations of T2. Okay, let's check the any conflict pair with the any transaction. Yes, read of Y. Now, W of Y is conflict with the read of Y. So, we have to draw the edge from T2 to T4, T2 to T4. Okay. Now, we draw the precedence graph for this transactions, for this schedule. Okay. Now, check whether this is having a cycle or not. Let's see, is there having any cycle? we can see that there is a no cycle is there. Okay, no cycle is there. It means the graph, our schedule is the conflict serializable schedule. Okay, this is the conflict serializable schedule because we don't have any cycle in our precedence graph. The next is the conflict serializable schedule are always a recoverable schedule. Okay, always remember this thing that the conflict serializable schedule is always a recoverable schedule. Therefore, the given schedule is recoverable schedule. Okay, there exist no dirty read operations. Alternatively, we have to see that is there any operations is there any other conditions for the checking that schedule is recoverable or not. So we are checking here the dirty read operations. I will tell you in another slide, next slide, what is the dirty read operations. So there is no dirty read operation. This is because all the transactions which updated the value commits immediately. Okay, which value are updated in the transactions are commits immediately. So there is no any dirty read operations. The given schedule S is a recoverable, also S is a cascadeless schedule. Okay, cascadeless schedule because every transaction is committed after updating his value. After updating his value, the transaction is committed. So it is the cascadeless schedule. Okay, these are the examples of the conflict serializable or non-conflict serializable. The next one is the view serializability in the Dbms. What is the view serializable in the Dbms? In a given schedule is found to be view equivalent to some serial schedule. Okay, if a given schedule is found to be view equivalent to some serial schedule, then it is called the view serializable schedule. If any one schedule is given there, we are checking their sequences. Okay, we are checking their sequences like T1, T2 and T3. These are the transactions which are given in a schedule. We have to check that is the view serializable schedule and not or not view serializable schedule. For that reasons, we are checking the sequences. These sequences, there are how many possibilities of these sequences like T1, T2, T3, then T1, T3, T2, after that T2, T3, T1, T2, T1, T3, after that T3, T2, T1, T3, T1 and T2. Okay, these are the possibilities for the given transactions. Non-serial schedule is equivalent to the serial schedule by checking these possibilities like 123, 132, 213. These are the sequences. These are the possibilities which we have to see for the checking view serializable schedule. We have to check all the sequences. View equivalent schedule. Consider two schedule S1 and S2, each consisting of two transactions T1 and T2. Okay, each consisting of two transactions T1 and T2. Schedule S1 and S2 are called view equivalent if the following three conditions hold true. There are three conditions. There are three conditions for checking the schedule is view serializable or not. The first condition is the initial read must be same for all the data item. Initial readers must be same for all the data items. Like for each data item X, the transaction Ti reads X from the database initially in schedule S1. Okay, in S1, if transaction 1 is reading operations on data X, then in another schedule, that transaction T1 also read the data on data X. Okay, that is the initial read condition. The first condition is initial read condition. Initial read must be same in both the schedule. Okay, the second condition is write read sequence must be same. In transaction, T1 reads a data item that has been updated by the transaction Tj in schedule S1. Okay, then the schedule S2 also transaction T1 must read the same data item has been updated by transaction Tj. We can see that the transaction which are updating the value will be the same in the schedule 2 also, which is updating the value. That means write read sequence must be write sequence must be same. Okay. The third condition is the final write must be same for all the data items. Okay. In schedule 1, if write operation is performed on the A data set or X data set, that means in another schedule also the write operations will be performed on the same data in same transaction. That is the final write operations. Like we can see that for each data item X, it has been updated last by transaction Ti in the schedule S1. Okay, transaction Ti which is updated by transaction Ti in schedule S1. Then in schedule S2 also X must be updated at last by transaction Ti. Okay, if in transaction in schedule S1 the final write will be performed by the transaction Ti, means if we can say directly if the final write will be performed by the T3, then in schedule S2 also the final write will be performing by the transaction T3. These are the three conditions for the view serializability, for checking the view serializability, for checking the schedule is view serializable or not. We will see the example of this view serializability is in another video. Thank you.